In the year 2018, inside a stone chamber at the Saqqara necropolis, the ancient Egyptian burial ground located approximately 30 kilometers south of Cairo, a team of researchers from the University of Catania, Italy, led by analytical chemist Dr. Enrico Greco, opened a sealed ceramic jar. The jar had been sitting in that tomb since approximately 1200 BCE, 3,200 years earlier. Inside was a solidified white substance that defied immediate identification. When the mass spectrometry results came back from the laboratory, the conclusion was unambiguous. It was cheese. The oldest solid cheese ever found in the history of human archaeology, confirmed and peer-reviewed, published in the journal Analytical Chemistry. The paper has since been downloaded and cited by researchers across 4 continents. Today we are going inside the tomb of Ptahmes, inside the jar that sat undisturbed for 32 centuries, and inside the scientific investigation that turned a lump of ancient dairy into one of the most surprising food history discoveries ever published. This video covers the specific timeline, the exact location, the confirmed analysis, and the detail that most coverage of this story deliberately omits: the biological contamination found alongside the cheese that rewrites our understanding of ancient food safety. Nothing in this story is speculation. Every fact is documented, peer-reviewed, and confirmed. In every detail, this story is a case study in how a single archaeological object can collapse the distance between 1200 BCE and the present day. The tomb in question belonged to a man named Ptahmes. He was not a pharaoh, but he occupied one of the most powerful positions in the Egyptian administrative world during one of Egypt's most celebrated eras. Ptahmes served simultaneously as mayor of Memphis, the administrative capital of ancient Egypt, and as high priest of the sun god Ra during the reigns of Pharaoh Seti and Pharaoh Ramesses II. His active period fell roughly between 1290 and 1213 BCE, which historians classify as the New Kingdom period, the era of Egypt's greatest imperial expansion. Memphis was the beating heart of Egyptian political life, and Ptahmes effectively ran the city. That dual authority made Ptahmes one of the few individuals in the Egyptian empire capable of exercising both political and divine legitimacy in the same office. The significance of Ptahmes' dual role, political administrator and religious authority, cannot be overstated in understanding why his tomb was exceptional. In ancient Egypt, political power and religious authority were deeply intertwined, and an official who held both was among the most influential individuals in the kingdom below the pharaoh himself. His tomb at Saqqara was designed to reflect that status. Carved walls, painted murals, burial goods prepared for eternity, and food offerings selected with purpose, these were not accidental inclusions. Every item placed inside that tomb was chosen deliberately. The question of who chose to include cheese and why is one this video will return to. The physical scale of his tomb at Saqqara reflected this dual authority. It was not the largest tomb in the necropolis, but it was among the most elaborately equipped. Here is where the story takes an unusual turn before it even gets to the cheese. The tomb of Ptahmes was originally discovered in 1885 by the Italian archaeologist Ernesto Schiaparelli during excavations at Saqqara. Artifacts were catalogued and some were removed for study in European museums. But then, with the speed and silence that only the Sahara can manage, the tomb disappeared. Desert sand accumulated over the entrance, burying it completely. For over a century, the tomb of one of ancient Egypt's most powerful officials ceased to exist in the practical sense. Its location was unknown, its contents unseen, its secrets locked. It would remain that way for 125 years. That disappearance is itself a reminder that the desert does not simply preserve the past, it selectively reveals it, on its own schedule. In 2010, an Egyptian archaeological team working at Saqqara uncovered the entrance to the tomb of Ptahmes during a systematic excavation. The rediscovery made immediate waves in the Egyptological community. Here was a high-ranking official's tomb, lost for over a century, intact in ways that sand burial sometimes uniquely preserves. Excavation resumed carefully, cataloging everything with modern archaeological precision. Among the hundreds of artifacts uncovered in the subsequent seasons of excavation was a ceramic storage jar, broken but not empty. The cloth that had once sealed its opening had partially survived. The substance inside it was dense, white, and chemically unusual enough that the team knew it required specialist analysis. The rediscovery was confirmed through cross-referencing artifacts already catalogued in European museum collections against items found in the newly uncovered chambers. Samples from the white substance were transported to the University of Catania, Italy, where Dr. Enrico Greco's laboratory conducted a rigorous, multi-phase analysis. The methodology involved proteomics, the systematic identification of proteins from degraded biological samples, combined with liquid chromatography mass spectrometry, one of the most precise analytical tools available for identifying ancient organic compounds. This approach is capable of identifying the origins and composition of biological materials even when they have been degraded for thousands of years. What it requires is not a perfectly preserved sample. It requires enough identifiable protein fragments to reconstruct what was there. The Saqqara sample provided exactly that. The sensitivity of the methodology was sufficient to detect protein fragments that had survived 3,000 years of thermal cycling, microbial exposure, and physical compression inside a broken ceramic vessel. The results of the analysis were clear and repeatable. The white substance contained milk proteins, specifically proteins associated with bovine milk from cows and with either ovine milk from sheep or caprine milk from goats. The blended multi-species nature of the milk source was consistent with ancient Egyptian animal husbandry practices, where cattle, sheep, and goats were all kept and managed for various purposes. The protein structure also confirmed fermentation, a biological process that converts milk sugars into acid, causing milk proteins to coagulate and form a solid. This is, in its most fundamental form, the definition of cheese. The Analytical Chemistry paper published the confirmed findings in 2018. The paper specifically noted that this was the first confirmed identification of a solid fermented cheese product from ancient Egypt, and potentially from the ancient world at any comparable age. Reconstructing the production method of a 3,200-year-old cheese requires combining the proteomics data with knowledge of what was technologically achievable in New Kingdom Egypt. The protein analysis points toward a solid fermented dairy product rather than a fresh or liquid form. This is consistent with what food historians call a brined or pressed white cheese, similar in basic concept to modern halloumi, feta, or certain Middle Eastern varieties made from mixed milks. The process would have involved either animal rennet, the natural enzymes found in the stomach lining of young ruminants, or an acidic coagulation agent derived from plant sources. Both methods were within the documented technological reach of ancient Egyptian craftspeople. This would have made the cheese effectively inaccessible to ordinary Egyptians, positioning it not just as food, but as a symbol of privilege embedded in the burial ritual itself. The multi-species milk composition, mixing cow's milk with sheep or goat's milk, was not unusual in ancient dairy cultures, but in the context of Egypt, it was associated with elite production. Cattle in New Kingdom Egypt were valuable working animals. They plowed fields and served important roles in religious ritual. Cow's milk was a luxury item compared to the more accessible milk of sheep and goats, which were kept in larger numbers by the general population. A cheese made from blended cow's milk and small ruminant milk was, in the most direct sense possible, a product of wealth and access. It was exactly the kind of food that ended up in the tomb of a man like Ptahmes, for exactly that reason. These facts align with what archaeologists have long understood about New Kingdom Egypt's dairy culture, that cow's milk products were status goods, not everyday commodities. Ancient Egyptians believed with complete conviction in the continuation of conscious life after physical death. The tomb was not a place of endings, it was a launching point for eternity, and it had to be prepared accordingly. Food offerings were an absolute standard of elite burial practice throughout the New Kingdom period. Bread, beer, roasted meats, fruits, oils, and honey appear consistently in the tomb inventories of wealthy officials and nobles. But a preserved, fermented, solid dairy product, cheese, represented something additional beyond ordinary food. It was preservation within preservation, a fermented food placed inside a sealed jar, inside a sealed tomb, created to last beyond any reasonable expectation of need. It was preservation logic carried to its logical extreme, storing an already preserved food inside an airtight container, inside an architecturally sealed structure designed to last forever. There is also a deeply practical logic to selecting preserved food for a burial offering. Cheese undergoes a biological transformation that extends its shelf life far beyond raw dairy. The fermentation process lowers pH, inhibits microbial growth, and creates a structurally stable product. Salt, pressed curds, and thyme, these were not just flavor choices, they were preservation strategies that ancient food producers understood empirically, even without knowing the microbiology. The Egyptians were, above all else, a civilization obsessed with preservation. Their mummification practices, their architectural permanence, their painted tomb walls, all of it reflects a culture that took the idea of lasting far more seriously than most. Including a preserved food in a burial context was entirely consistent with that worldview. The Egyptians had developed techniques for drying, salting, and sealing food that were, in their own empirical way, as sophisticated as anything that followed for the next 2,000 years. Before we get to the detail that most coverage of this discovery leaves out, and it genuinely changes the meaning of what was found in that jar, take 1 second right now and hit the like button. Subscribe if you haven't yet. This channel exists to find the story's history buried and the details everyone else skips. Every like and subscription helps us reach more people who want that. Now, back to Ptahmes and the thing hidden inside the cheese. When Dr. Greco's team completed their full proteomics analysis, they found something in the white substance that was not dairy protein. Mixed into the molecular evidence was a protein signature associated with Brucella melitensis, the bacterium responsible for brucellosis. Brucellosis is a zoonotic disease. It originates in animals and transmits to humans, most commonly through the consumption of unpasteurized dairy products, raw meat, or direct contact with infected animal tissues. Its symptoms include prolonged undulant fever, joint and muscle pain, fatigue, and in severe or untreated cases, complications affecting the central nervous system, cardiovascular system, and liver. In the modern world, brucellosis is treatable with antibiotics. In 1200 BCE Egypt, it was not. The most important implication of the Brucella finding is not historical, it is epidemiological. It demonstrates that the animal-to-human disease pathway that drives modern food safety law was active, documented, and deadly 3,000 years before anyone built a regulatory framework around it. The presence of Brucella melitensis proteins in a 3,200-year-old cheese sample means that the livestock that produced the milk for this cheese were almost certainly infected with brucellosis at the time of production. Infected cattle, sheep, and goats shed the bacteria directly into their milk. Without heat treatment, without pasteurization, which would not be developed as a formal process until the 19th century CE, that bacteria passed directly into the dairy product and potentially into anyone who consumed it. Brucellosis in ancient populations would have been difficult to distinguish from other febrile illnesses. It has a long and unpredictable incubation period ranging from 1 week to several months, which makes tracing it back to a specific food source extremely difficult, even with modern diagnostic tools. The incubation period of brucellosis meant that anyone who contracted the disease from this cheese may have become ill weeks or months after consuming it, making the connection to a specific food entirely invisible to ancient medicine. This finding represents one of the oldest confirmed identifications of a foodborne pathogen in the entire archaeological record. The Saqqara cheese is not just the oldest solid cheese ever found, it is also evidence of an ancient disease pathway that connects directly to public health practices we still debate and enforce today. Raw milk regulations, pasteurization requirements, food safety protocols, these modern systems exist precisely because of the risks demonstrated in this 3,200-year-old jar. The bacteria that contaminated Ptahmes' burial cheese is the same species that infects approximately 500,000 people globally every year in the 21st century. It did not go away. It simply became visible to science. This is not a story of ancient ignorance. It is a story of ancient limitation, and the difference between those two things is everything. The Ptahmes cheese discovery functions as a confirmation of what food historians had long theorized but rarely been able to prove with physical evidence. Ancient dairy production was technically sophisticated by at least 1200 BCE, involving intentional fermentation, multi-species milk blending, and the production of solid preserved cheese for elite consumption. The Egyptian New Kingdom was not a culture of casual improvisation. These were people who built the temples at Karnak and Abu Simbel, who maintained complex trade networks stretching from Nubia to the eastern Mediterranean, and who administered an empire through written records and hierarchical bureaucracy. Their food systems reflected that same organizational sophistication. The artifact bridges the conceptual gap between ancient subsistence and modern industry, proving that the technological knowledge required to produce preserved dairy existed at scale long before it was documented in formal written records. Cheese itself existed long before Ptahmes was born. Residues of dairy fat on ancient pottery fragments found in Poland have been dated to approximately 5500 BCE, suggesting that cheesemaking or acidified dairy processing was occurring in Neolithic Europe more than 7,000 years ago. Pictographic evidence from ancient Mesopotamia and the Fertile Crescent references dairy production and cheese-adjacent foods going back at least 6,000 years. Egyptian tomb paintings from as early as 2800 BCE depict what researchers believe are representations of dairy processing. What the Saqqara find adds to this history is not the existence of cheese, it is the physical evidence. A testable, datable, chemically confirmable sample that puts a concrete anchor in what was previously a chain of inferences. In that sense, the Saqqara cheese is not just a food artifact. It is a scientific instrument capable of producing new knowledge about ancient biology with every analytical methodology that is applied to it. The 2018 paper in Analytical Chemistry was peer-reviewed, widely validated, and subsequently cited in numerous academic studies on ancient food systems and ancient disease vectors. Dr. Greco's team used methodology that is the current standard for ancient proteomics research, the same technique that has since been used to identify ancient proteins in everything from cave paintings to Bronze Age bone fragments. The Saqqara cheese was not a lucky guess or a headline-chasing interpretation. It was the result of careful, documented, reproducible science applied to a 3,200-year-old artifact that had been sitting in a storage context since before Homer wrote the Iliad. The paper has since been cited in academic studies on ancient microbiology, ancient dairy cultures, and the evolutionary history of zoonotic disease. The site of the discovery, Saqqara, deserves its own note as context for why this find was possible at all. Saqqara is one of the most dense and continuously excavated archaeological zones in the world. The Step Pyramid of Djoser, built around 2650 BCE, stands there as the oldest complete stone building structure in human history. The site contains thousands of tombs spanning 3,000 years of Egyptian civilization, ranging from royal mortuary complexes to the tombs of court officials, priests, and wealthy citizens. In this context, finding extraordinary artifacts at Saqqara is almost expected. What was not expected was that one of those artifacts would rewrite the global record for the oldest confirmed solid cheese, and do it from inside a sealed ceramic jar. The Step Pyramid alone makes Saqqara one of the most significant single sites in human architectural history, and the cheese found in the tomb of Ptahmes makes it one of the most significant sites in food history as well. If you made it to the end of this video, you already know this channel is different. We do not cover cheese for the taste. We cover it for the history, for what it reveals about power, civilization, science, and the extraordinary things human beings have chosen to preserve across thousands of years. If this story earned it, hit the like button right now. Subscribe so you do not miss what is next, and leave a comment below with the only question that matters. Would you have eaten that cheese, or does the word brucellosis change your answer? We read every single comment. See you in the next one.